Hello, everyone. How's the energy here today? Still good? Yay! Or are we all a little bit tired from all the talks? Oh, I try to keep it easy, not really technical today, to help. Easy is important, exactly. What am I gonna do today? I'm gonna say the word data a lot. Just be warned. I'm going to take you through a journey of what's blocking the next generation of AI, in my opinion. And that's going to be data. That's the first time I said data. Let's do something first. Like by raise of hands, who here is actually from Poland? Okay, not that much. Okay. And who has been here since morning? Raise of hands. Okay, no, okay. So what I just did is collecting essentially data. I know now something about the audience could be useful for me, could be useful for the organizers, but I have now data. It's not maybe super useful data, but could ask more questions. What is data? And what I'm trying to say is data is all around us. It's everywhere. And people say data is the new oil. And I would like to argue that data is really like the new oxygen. Because in this society, without data, we cannot function. Like data is it's everywhere. You know, it's generated and consumed when we use public transport, when we are on our phones, when we order food. It's used really everywhere. The problem with data is it's very hard to obtain. The data that's already generated, it's not freely available or easily available. And there's a problem that I want to discuss, because let's take an easy example, for example, from an insurance company that does car insurance, and they give out small devices to the people, the drivers, that they plug into their OBD port in the car, and then they generate data about how they drive, whether they drive carefully or a little bit wilder. And that data is going to be used to calculate the premium of their insurance. So if they drive really carefully, they get less, they pay less, right? That data then served its purpose, meaning it reached the goal, and the data is then somewhere on a server, siloed away, not available for anyone anymore, which is maybe a little bit wild, because that data could be useful for other business startups, maybe even could be useful for conducting research. And it's a hassle to sell that data, and then to also reward the original creator of the data, the driver, for a part of their revenue. And there is another problem with the current reality, is the data that is available, you get issues like this. You know, just recently, maybe not so recently anymore, but the New York Times, they sued OpenAI because they scraped millions of articles from the New York Times in order to train their large language model, right? And we can go back and forth whether who is in the right, who is in the wrong, doesn't really matter. The fact is that there is an increasing amount of companies that generate content, data, that are trying to make it harder to get access to the data. Data is, for example, locked behind paywalls. They are applying anti-scraping measures, stuff like that. And because of that, all different mechanisms, it makes it harder for creators of models like this, like OpenAI, to have access to that data, which makes the next generation of AI more difficult. And yeah, we can say it's simply going to get harder to get access to more data. But there is another problem. There are a couple of other problems. But another major problem is that besides the fact that it's harder to obtain access to data, there is, if we look specifically, zoom in on large language models, generative AI, specifically the large language models, the chat ones, they have a problem that they hallucinate. So they're trained on massive amounts of unstructured data. And there is a big lack of access to structured data. So let's stop a little. What is structured data? What's unstructured data? Unstructured data, structured data, it's, for example, what you have in a spreadsheet is predictable. It has a structure, a single format, and you have a bunch of records. And if it's a record about objects that you can buy, one of the columns is price, for example, and that price can be different between records. It could be $70 in one, it could be $200 in the other, but it can never be purple or Amsterdam. It will always be a dollar amount. That's structured. Unstructured data is everything else. It can be a news article, conversation between people. It can be an image, a video, an audio clip. It's data that's not very predictable. It's not very structured. Structured in a sense, but not structured as typical structured data. And having more structured data available to large language models will help large language models to come up with factual information, meaning that it will hallucinate less. Because all this unstructured data means that they can have excellent conversations, like they're excellent conversationalists. So it's very nice piece of text, but if you're gonna any logical reasoning with an LLM, it falls apart. And it's not as easy to say, okay, we give it a bunch of structured data sets, and then they will know what to do. It's not enough, because structured data needs to be contextualized. Because without contextualization, you have no idea how to interpret that data. So to zoom in a little bit on contextualization, what that is, here's an example of Wikipedia. It's maybe not a perfect example, but makes it absolutely clear how powerful contextualization can be. If we pick apart a Wikipedia page, you have two big elements. You have at the bottom, you have a list of sources, references. These are important because through these references, you essentially prove that what you state in the article above is true, can be verified. That list of references is structured data, because every reference, it's a number, it's a URL, it's a description, and the next reference is the same. So it's a predictable structured format. If you just have a Wikipedia page with only structured data, only these references, nobody understands the topic. They will have to go through all these links, read it, and they know that all of this combined is this topic, but how the context behind these combinations is unclear. So you have the page above with the paragraphs. That's unstructured data, by the way. Can contain images, can contain videos, tables. But through reading that page, you know the context of all these sources, essentially. So the same goes for any kind of structured data set. If we give it to an LLM, we need to add that context. So we need to have mechanisms in place in order to have contextualization through metadata, so that the data can be fed through LLMs, and the LLMs knows how to interpret it. So for LLMs, we already have kind of a solution through retrieval augmented generation, RAG. And what it means is that you don't have to train a model on your business data, your structured data, for it to use it in its reasoning when it's answering you. So let's pick that apart a little bit to make this digestible. If a business creates a custom LLM, it can give it access to its own data, its business data about clients, about products, stuff like that. So that when, for example, an LLM is used for customer support, it can, while generating the response, check the documents, the databases for the factual information and take that into account for its answer, which is cool, which means everything I said doesn't matter. There is no problem. We already have the solution. Not true, because this is a very individual approach. This works for a single business, a single use case. So if we want to have truly a next generation of AI, where we bring all the world's data together, not necessarily for free, but then at least with fair rewarding mechanisms, revenue distribution mechanisms, data governance and stuff like that. We need to go a step further than having just a rack for individual use cases where we can unlock all the world's data into an LLM. And we can also solve issues like New York Times. We can say, if an article from the New York Times is used as a reference, then you have to pay a little bit for it. As an example. Not say I agree, but it could be done. So what I'm essentially talking about, what I see in the future, is a completely new data economy, which is essentially forming an ontology of the world's data. Ontology is an interesting word. What does it mean? An ontology, it's a combination of properties about something. So here it's an example of a pizza. Pizza contains topics. You have different types of pizza. So you see all the hierarchy between those elements. So we can do the same with structured data and unstructured data from the whole world. So if we bring all of this data together and we are able to form the connections and combinations between this data, we can essentially form an ontology of the entire world, the entire universe. Of course, it's kind of utopian what I'm saying here. It's very ambitious, but every step towards that will be an improvement of the current situation. We'll probably never really fully realize the world's or the universe ontology, but we can come really far. And something very underrated, what is also needed in order to get that ontology, is reference data. And reference data is the boring type of data. It's not worth anything. Does it belong to a business? It's just data that is. It's virtually non-changing or very slow changing data, but it's useful for use as reference. Like we can talk about the flag of Poland, but with reference data, you would include information as that has a red part and it has a white part, and which order they are. And as an example here in the presentation is the periodic table. Periodic table is a perfect example of what reference data is. It's not owned by anyone. It just is, and it can change, but it's very slow to change. And if you have a data set, a business data set that reference an element, it could be further extended with information from a reference data set that includes this. So we need to have, we need to accommodate a bunch of reference data sets to allow to onboard them, to allow free contributors, like on Wikipedia, that onboard these data sets, that are rewarded in some way, because only then we can have a full ontology. Because now I mentioned all these problems with what I see, what's data, what's still needed. And then there's synthetic data. And there's a really interesting story here. This tweet was very counterintuitive. So let's first come to what's synthetic data. Synthetic data is essentially an extrapolation of existing data. It's filling in the gaps. If you want more of that data, you're going to make that up by algorithms, averages, using an AI model to come up with that data. And you come to synthetic data so that you have more of the data, but the data isn't real. There was a discussion, well, there are several discussions about what happens to large language models when they are going to be trained on their own data that they have generated. Because there's a lot of concern that with this huge influx of LLM-generated content, is it going to be of any high quality in the future? Because it's trained on its own data going forward. And I think that situation is very similar to a situation where we speak about synthetic data, because there's also AI-generated data. There's also algorithmically generated data. So it's very similar. And you would expect from that discussion and from intuition that having more fake data will make an generative AI worse or flatline. It will hit its ceiling. And this shows that having a lot of synthetic data actually makes the model perform better than the current models, which is insane. And in a way, it maybe makes some sense, because if you think about it, I think maybe, and this is not based on anything, but just follow my thoughts for a moment. I think maybe as humans for humanity, we kind of already wrote everything. It's already all out there. It's just not all the different combinations between content, between information, put together. So it's like any type of innovation. When you innovate, you take existing stuff and you mix it together differently, and you have something new. It's not like you start completely from scratch, because that would mean you have to come up with new particles, molecules, and then build on top of that. That's, I think, kind of the same with the content that we put out there. So a lot of unstructured data can be put into new combinations through synthetic data, and we can come up with new things. And not sure if this is true, but it makes sense. So then everything what I said before, is it bullshit? Is it not an actual problem anymore because we have this? No, because this is largely for unstructured data. We still have the same problem for all the business data, all the other data, reference data that's structured, for which you cannot generate synthetic data. Well, you can, but it doesn't really make sense, because then you're actually gonna make factual data not factual anymore, because you're gonna extrapolate the data with a bunch of bullshit. It's not true anymore. So what do we need to move forward? And this is what we are building at Nuclei. I'm founder and CEO of Nuclei. Nuclei is building layer 1 infrastructure to exactly accommodate all of this, what I've just mentioned. So easy onboarding of data, so the data is immediately interoperable. The data is in the same format, data from completely different industries, different countries, different formats, can be all accessed in one query without building the different connectors for every data set, have access to reference data, where the data can be easily contextualized, so that this data can be understood by AI, by humans, where data can be infinitely combined to create ontologies, and where it can be leveraged as like one big API, because now having access to a lot of different data sources, you have a new API, you need to connect to a database, so it's really time consuming, it's really expensive. So having infrastructure that allows builders to build things on top of it, leveraging all of the data that's in it, gonna save a lot of time. And the important thing is that that ecosystem needs to be collaborative. It needs to be a place where people can contribute freely, can be rewarded for the contributions, and can develop solutions, can build their own startups on top of it. And this is why blockchain matters, and how it helps to build the next generation of AI. Because look, having an ecosystem with all the data, it cannot be owned by a single entity. It cannot be owned by the next Google or Meta or whatever. It has to be decentralized. Because if we put all the world's data there cannot be one owner. We have to all collectively own it and maintain it. So that's why we believe our contribution is building in that decentralized infrastructure to accommodate all of this. And that's it. Thank you. Any questions?
What? I cannot hear. So I have a question. Can you value our personal data of an average person? How much my data on social media, my where do I go with my car? Can you value it as one person?
No. Well, I can't, for sure. And I also don't think that we should look at it like this individually. And there is a lot to say about personal data, social media data. We don't really focus, I don't really want to focus on personal data. It's more about the data that is that we generate around us. Like when we drive a car, it can be about what kind of inputs that we give into the car without revealing our name. It's unnecessary, right? But if we collect personal data or any data, and we put that together in a single data set with all the contributions of all the different people, that data set is worth more than just your data. So we'll make it more, and also more useful. You can leverage for more use cases. So that bunch of data with a bunch of records from a lot of people can be very valuable to a business, and it will pay for that entire data set. And then everyone who did a contribution will get a percentage of the revenue generated, the fair percentage of concerning of the contribution that you made, the size of your contribution, right? Makes sense?
Yes. So we can't say like when we have a group of people, we can say what is the most value data from day, because it depends on what our language model do. Yes?
Sorry, can you elaborate a little bit?
It's pretty hard. Like, is there any data that is the most important for like the big group of people, for companies, or
No,
or it depends what they want?
yeah, of course, it's use case depending. Like, I speak a lot about large language models because it's very on top of our minds, right? And everyone, I'm sure here, probably everyone has been using one or testing with it or use it on a daily basis for development or whatever. And there are a lot of use cases around this for code generation, but also for business, for their customer assistant, LLM and stuff like that. There is also a lot of really boring AI use cases to improve supply chain. Which also requires an AI model. But it's incredibly boring, but it also needs solutions like this. So, but all next generation AI or any type of innovation will need data, and will need more of that. So all the problems are the same. And there's no, like, I think a lot of personal data is very valuable because of the fact that it can be used for marketing purposes. But there's supply chain improvements require a lot of data around truck routes and geographic stuff and stock values. Yeah, it's most valuable to them is that kind of data, for example.
I have a little bit of a random question.
Nice.
So there's this concept of Internet of Things, and it feels to me that this product kind of fits into that concept. However, there was a lot of talking about it, I feel, several years ago, but then it's quieted down. So what is happening? Is Internet of Things coming or not?
Internet of Things?
Yeah, like this concept where you have one network where basically all the devices that can connect to the internet can easily connect and integrate with it.
Yeah, good question.
Because that way, it would make it very easy to collect the data for your model.
Exactly. Internet of Things is huge. It's really big at the moment. There's a lot of devices out there on the street in houses that run on a SIM card that phone home with data. Internet of Things rely on data in order to, because they have no interface usually, they rely on data exchange. Very important. And in the world of Web3, Internet of Things is deep in. And actually deep in and everything that we stand for, they go hugely hand in hand. For example, we have a partnership with Peak Network, especially to work on all things deep in around data exchange, trustful data exchanges, verifiable data exchanges and stuff like that.
All right, so still there's a lot of technologies not in place, but it is moving forward rapidly, you would say.
Absolutely, and there is also already a lot in place. We just contribute. There's one there for a while.
Thank you for your presentation, Alexander Kvaskov, FinTech Association. And my question, I read that for launch validator of your network, I need $1.5 million tokens.
Yeah.
Yes, and it's $4,000.
Yeah, right now it could be.
Right.
Yeah.
Yeah. And I need stake this amount, but can I get it from, maybe you have DAO, and I can apply it like validator with
A delegated stake?
yes.
Yes, it's possible. I mean, it's possible once we have mainnet. We are still on testnet right now.
Right now testnet.
Yes, exactly. Yeah.
And I can be participation in testnet.
In the next 2 months, when we're going to be accepting outside validators, right now we run all of them ourselves. It's more of a devnet than a testnet. But testnet, where we will invite people to run their own validators, coming in like the next 2 months, something like that.
Okay, well, you just know I'm interested in.
Okay, well, let's connect.
Yeah, thank you.
This will be the last one.
Huh?
Like,
hello.
Hello. Oh, perfect. I strongly agree that like blockchain data is highly structured and will be very valuable. You mentioned contextualizing it makes it more important for large language models that are able then to like get the semantic meaning of this data out. I would kind of have the feeling that like the contextualization is the fastest thing to degrade with blockchain data because it's very expensive. So you're very selective about what you put on chain, and the surrounding context is like almost too expensive to put there. So how are you guys thinking of tackling that in the long term and like preserving this this contextualization?
Yeah, easy. We don't put the data on chain. So we are not decentralizing data itself. If you decentralize all the world's data, it's very highly inefficient. Like data storage is not so expensive anymore, but then it's going to become very expensive. So it's more about, like many businesses will not also allow to put their data on chain. It's impossible. Like they want to keep data governance themselves. So we need to allow them to give them decentralized controls, mechanisms, to allow someone to trustlessly purchase access to this data and to have access to like distributed GPU networks and stuff like that, and have this decentralized reward mechanisms in place so that all the contributors will always be fairly rewarded when value flows through that ecosystem. Thank you. Wonderful audience.